Hi, I'm Paul Keoghan from Gktuition, and in this video I want to talk to you about functions and algebra. Now the question that I've chosen to go through here is 2018 paper 1 question 5. In this question, in the first part, we're given a curve like this, and they've labelled the point A, the point B and the point C, and they've asked me to fill in the coordinates of these 3 points. So in this case, right, let's start with A. If I look at A, clearly the vertical line is your y-axis. So in this scenario, the y value is 6. Remember that when we're dealing with coordinates, the second coordinate in your point is the y value. So I know the y value there is 6. And since it's on the y-axis, the x value must be 0. If I look now to B, clearly in this one, my x value, the horizontal line is always the x value. The x value is -2. And since it's on the x-axis, the y value must be 0. For part C, the x value is 3 and the y value is 0. So you get your marks there just for filling those in. So there are your 3 coordinates, A, B, and C. So in the second part of this question, we're asked to prove that the function can be written as -x² plus x plus 6. So you need to hone in here. In terms of the graph, you need to look for the roots. The roots are the points where the curve crosses the x-axis. So the curve crosses the x-axis at B and the curve crosses the x-axis at C. One of my roots is x equals -2, the other root is x equals 3. I'm just identifying the points where it crosses the x-axis. Once you have the roots, in order to get the function, I need to turn the roots into factors. If x equals -2 is a root, you add 2 to both sides and you end up with x plus 2 equals 0. So one of your factors is x plus 2 equals 0. If x equals 3 is a root, you subtract 3 from both sides, and your other factor is x minus 3 equals 0. Now that you know the 2 factors, in order to come up with the equation, you just need to multiply them by each other. So I need to multiply x plus 2 by x minus 3. So I'm just going to multiply one factor by the other. It's double brackets here, so it's the first thing in the first bracket by the second bracket, plus the second thing in the first bracket by the second bracket. X by x minus 3 plus 2 by x minus 3. If I multiply it out, x by x is x squared, x by -3 is -3x. 2 by x is plus 2x, plus 2 by -3 is -6, and that's equal to 0. Now, all I need to do now is group my like terms, so I get x squared minus x minus 6 equals 0. But clearly, if there's a plus in front of your x squared, that means that it's a U shape. But the graph I have is an N shape. In order for a quadratic to be an N shape, then the value in front of the x squared needs to be negative. So it must be a minus x squared. If it's a minus in front of the x squared, it's an N shape, whereas if there's a plus in front of the x squared, it's a U shape. So all you need to do here is rewrite this. I basically just need to bring everything to the other side. Imagine, so I'm going to say the left-hand side now becomes 0. If I brought my x squared across, it becomes minus x squared. If I bring my minus x across, it becomes plus x. If I bring my minus 6 across, it becomes plus 6. So therefore, I can now say that the function can be written as minus x squared plus x plus 6. So let's just leave it exactly the way they wrote it in the question. I can say the function is minus x squared plus x plus 6. Okay, so for part C of this question, we're asked to show using calculus that the maximum point of this function is 0.5, 6.25. In order to do that, so using calculus, they're obviously talking about differentiation. In order to identify either a maximum point or a minimum point, you need to get the first derivative and let it equal to 0. If you get the first derivative and let it equal to 0, you'll be able to find the value of x for which there's a turning point. So the first thing I need to do is differentiate. If I know f of x, I need to get f dash x. So to get the derivative of minus x squared, I just bring the power in front. So it becomes minus 1 by 2, which is minus 2x, and the power decreases by 1, so it becomes minus 2x to the power of 1. You can view this as x to the power of 1, so the 1 comes in front, and it's plus 1 times, and the power of x decreases, so it becomes x to the power of 0. Which is just 1, but we don't need to put it in. So the derivative of plus x is just plus 1. The derivative of 6 is 0. So my first derivative here is just minus 2x plus 1. Now, in order to identify a turning point, you need to let your first derivative equal to 0. So I'm going to let minus 2x plus 1 equal to 0, and I'm going to solve for x. So in order to find the value of x, I just say that means that minus 2x must be equal to minus 1. So if I divide both sides by minus 2, I'll get the value of x. So x is minus 1 divided by minus 2, so your x value works out as 0.5. So that proves that that the maximum point exists when x is equal to 0.5. Doesn't necessarily mean that the corresponding y value is 6.25. So now that we know that that's definitely the x value, I now need to verify that the corresponding y value is 6.25. And in order to do that, you're going to sub into your original function. Okay? Remember, if you're writing this as f of x equals quadratic, your f of x, you can just view your f of x as your y. So what I need to do here is I need to sub in x equals 0.5 and verify that when I plug that in, my answer is going to be 6.25. So in order to do that, I'm just going to say that y is equal to, instead of an x, I'm going to put in minus times 0.5 to be squared plus 0.5 plus 6. And if you plug all of that into your calculator, the corresponding y value is 6.25. So you know that when x is equal to 0.5, y is equal to 6.25. And happy days, that means now I know that the maximum point exists at the coordinate x equals 0.5 and y is 6.25. So I can just take that and say that it's true. So I hope that video makes sense. If there's anything you're unsure of there, or you want me to explain it differently, then just let me know in class and I'll try and clarify for you.